Hi, I'm Alex Garcia, and thanks for joining us here at NTWC Live. It is a team effort between Bill Reed, Tim Smith, and I. We'd like to say thank you to a few groups that helped make this possible. It's USAA, South Padre Island Convention and Tourist Bureau, the Weather Company, and the Weather Boy. And now, here's Tim Smith.
Thank you, Alex Garcia, and good morning, everybody. Welcome to NTWC Live for Wednesday, August the 10th. It's a big day here at NTWC Live. We'll get to all the fun in just a second, but before we go any farther, let's thank our sponsors, USAA, the South Padre Island Convention and Visitors Bureau, the two biggies that have been part of us from the very beginning. We thank both of them for all of their support. The Weather Company, City of Brownsville, Black Magic Design, Weather Boy, the Port of Brownsville, Walmart, all part of what we're doing. So thanks to all of them for being part of this. Our guest today is going to be Dr. Phil Klotzbach, who's going to update the seasonal hurricane forecast. Also with us today is Dr. Hal Needham, who's going to have some amazing questions. As always, I'm sure we'll talk about your early morning dip in the Gulf of Mexico. And finally, our host, former director of the National Hurricane Center and the birthday boy, it's Mr. Bill Reed. Happy birthday, Bill. Good to be 21 again and again and again, isn't it?
Yeah. In my mind, I'm still 21, and then the body barks back. What can I say?
Good morning.
Bill would appreciate this story. People ask about where I was born, and I usually introduce it as something like this. I saw Ted Williams play in Fenway Park the day before I was born. Mom was a great baseball fan, and Dad was a Red Sox fan. We lived in South Weymouth up there, and she was due in a month, and they went there. It got up to 100 that day, which is really hot in Boston, and that's probably why I was destined to live in this climate. It was a little source and all that. But that's not the subject of today's seminar. So let me do a quick rundown of the tropics here. Hopefully I get that on right. There we go. Get that. There we are. All right. This morning's view of the weather phenomena going on in the Eastern Pacific. Here's a soon-to-be post-tropical system, maybe already. I'll have to check the latest update on Howard, which was briefly a hurricane paralleling the coast of Mexico, like virtually all of our storms have done out there this year. And down here south of Mexico is the next system, which is almost certain to form within the next 2 to 3 days and eventually become Yvette and follow a similar course that Howard et al. Have done beforehand. So we'll do a real quick look here. This is the outlook. It's at 50% on developing in 2 days and 80% over the 5 days. And it looks like everything's on track for that. I don't see any real inhibitor for that to go on. See if I got this right on Howard. Okay, it's still a tropical storm, and it's still forecast to become post-tropical, if not today, then tonight or early tomorrow, and begin to turn back to the west as it becomes nothing but a low-level swirl steered by the trade wind currents. Out to the east, a lot of weather in the Gulf of Mexico, but it's a lot of moisture, but underneath is a broad high pressure. The pressures remain high, no sign of any falling there. System came off of Africa a couple days ago that showed some promise, but shown a lot less lately, and is currently not looking very vigorous convection-wise. A lot of dust still coming off of Africa. It can be seen in the flow to the north of it, and dry and stable air is indicated by those clouds. And our outlook continues to hold the 20 to 30, but there's mostly discouraging talk as far as development and the discussion from the Hurricane Center. Of course, this is the time of year where we start looking over Africa, and Phil can enlighten us on some of this as he gives his talk. But again, it looks for 10th of August looks fairly quiet to me. A bit of a wave coming off down here that has a little convection with it right now. A lot of convection over the central tropical Africa, moving westward that might bear some watching, and perhaps another one behind that. and indeed, the ensemble runs from the European do show towards the end of its run out towards the 10 days of something maybe coming off the coast of Africa. But that's a long way off, and a lot of stuff could change between now and then. Okay, we go right into our guest. Normally I give a real straightforward introduction, but we can't let it go. The Greeks had their oracles. The tropical Atlantic people have our oracle on the mountain in Colorado, and Dr. Phil Klotzbach, and he's going to pontificate today on the latest thinking of the great seer. Have it, Phil.
Well, thanks so much, Bill. Very happy birthday to you. And yeah, so I'll be talking to you about our forecast update that we just put out a few days ago. And so basically, I'm going to start by talking about the hurricane seasonal outlook, and then we'll actually kind of step back and try to kind of fill in between the seasonal outlook and what we might be seeing over the next couple of weeks. Bill already started to allude to some of that, and we'll talk about, how I do think things are going to change. Obviously, Atlantic's been very quiet, but I don't think that's going to continue. And I'll explain a little bit as to why that's the case. However, keep in mind that I can and have been very, very wrong. So being a forecaster keeps you very humble, especially when you forecast hurricane seasons and then try to forecast peak or shorter periods during the season. There's a lot of chances to make a colossal screw up. So certainly, these forecasts have skill, but they have been wrong on occasion. So to begin with, this is our latest forecast. We call for a total of 18 storms, 18 named storms. That includes Alex, Bonnie, and Colin that have already formed. It seems like a long time ago now, because Colin died on July the 3rd. So we haven't had any storms in the Atlantic since the 4th of July. However, we have observed in the past that often these fairly robust La Nina years, which I'll talk more about here in just a minute, can start off fairly slowly. So perhaps some of this quietness that we've observed is typical with a fairly strong La Nina year, and I'll talk more about that in a minute. One thing I do want to draw your attention to is we also forecast accumulated cyclone energy. That's an integrated metric accounting for storm frequency, intensity, and duration. So, for example, a storm like Colin, which is out there for like 12 hours, generates very, very little ACE. Long-lived major hurricanes like Irma and Dorian generate tremendous amounts of accumulated cyclone energy. So we at CSU issue several forecasts throughout the season. Here is a look at the various forecasts with the most recent forecast in slightly larger font to kind of highlight it. We can see, in early April, we forecast an above normal season. It's been above normal at all lead times. We did lower our numbers in early August. A lot of that because our model guidance that we use actually came down a little bit. We were forecasting a busier season, and the model guidance from July to August came down somewhat. I'll talk more about the various model tools that we use to come up with our outlook here in a few minutes. But you can see, overall, we are still forecasting an above normal season. The average hurricane season has about 14 storms, 7 hurricanes, and 3 major hurricanes. Major hurricanes are hurricanes of category 3, 4, 5 on the Saffir-Simpson hurricane wind scale, winds of 111 miles per hour or greater. Whenever I do seasonal forecast talks, I always like to start by acknowledging the great contributions of Dr. Bill Gray, who was the founder of the Atlantic Seasonal Hurricane Forecast, a professor at Colorado State University for over 40 years. So he pioneered seasonal hurricane prediction. So prior to when he started issuing seasonal forecasts, there were no forecasts on seasonal hurricane activity. But in addition, he made fundamental contributions to tropical cyclone genesis, structure, intensity change, just a giant overall in the field of tropical meteorology. He was a great mentor to a bunch of students. I was his last PhD student, and certainly was blessed to have the opportunity to work with him closely work with him for over 15 years. But now to kind of dive into the seasonal hurricane forecasts. So, basically the way these got started was Dr. Gray was basically a fount of knowledge. He was basically a walking encyclopedia. And so he was teaching tropical meteorology. And in his tropical meteorology class, he taught about El Nino, which is warmer than normal water in the eastern and central tropical Pacific Ocean. And what he did was he noted that when you have El Nino, you tend to have fewer hurricanes in the Atlantic Ocean. So the question became, why would something going on in the tropical Pacific Ocean, so here on the left you see El Nino with warmer than normal water, and La Nina, basically the opposite with colder than normal water, why would those impact Atlantic hurricanes taking place in the Atlantic Ocean thousands of miles away? And basically, one of the things that Dr. Grace always talked about was that the global ocean and atmosphere function as a single unit. So when you change the water temperatures in the tropical Pacific Ocean, it then impacts not only what goes on in the Pacific Ocean, but also the Atlantic Ocean. And basically, the primary reason was that it's through changes in basically wind patterns at both lower levels, so near the ocean surface, and at upper levels, say 20 to 30,000 feet in the atmosphere. So for example, kind of the canonical answer is that when you have an El Nino, you tend to get much stronger upper level winds. So winds 20, 30,000 feet in the atmosphere get much stronger out of the west. Now your trade winds, the winds near the ocean surface, blow out of the east. So if we think about this in a vertical cross section, we can see low level winds one direction, upper level winds another direction. And what that tends to do is increase levels of vertical wind shear, which is the change in wind direction and speed with height in the atmosphere. Too much vertical shear is detrimental for hurricanes. Basically, it tilts the hurricane circulation, it disrupts the hurricane circulation, and you're less likely to get hurricanes, and certainly less likely to get major hurricanes. Alternatively, when you have La Nina, you tend to have lower levels of vertical wind shear, which is more conducive for overall Atlantic hurricane activity. And so this discovery of the relationship between El Nino, La Nina, and Atlantic hurricanes was one of the first predictors that Dr. Gray used with the seasonal forecast, because we can generally forecast El Nino and La Nina a few months out. These forecasts for El Nino and La Nina, like forecasting for anything, certainly aren't perfect, but in general, we can forecast with some levels of skill a few months into the future. And so, we use more than just El Nino and La Nina with our Atlantic hurricane seasonal outlook. So what I'm going to try to convince you of in the next few minutes is that in general, these precursor signals, or these signals in the atmosphere and ocean, are there several months before the season starts. So for example, here's a plot showing January through March sea surface temperatures, there's SSTs, for the 10 most active Atlantic hurricane seasons, difference from the 10 least active Atlantic hurricane seasons since 1950. So now we have hurricane data going back all the way to the mid-19th century, but obviously we have a lot better ways of observing hurricanes now than we did 170 years ago. So we have reasonably reliable data going back to around 1950. We also have sea surface temperature data, wind data, pressure data, all of this going back about 50, 70 years with reasonably good skill or reasonably good accuracy. So what we're looking at here is basically what makes an active hurricane season, or what kind of precursor signals are there. So we're looking here at January through March sea surface temperatures. So if we look at this plot, we can see warmer than normal waters, typically associated with above normal seasons, as indicated by the yellows and greens, all the way as far back as January through March. So we have precursor signals. Now, if we look in the Pacific Ocean, we see a little bit of blue in the Eastern Pacific, but not a very strong signal there. And that's because often, if you're going to flip between La Nina and El Nino, or vice versa, you're going to do so during the spring months. So now if we toggle ahead and look at April through May, we see a more robust La Nina-like pattern with cooler than normal water in the eastern and central tropical Pacific. We also see warm water in the Atlantic. You see that generally the strongest signal is in the subtropical eastern Atlantic, both in April and May, as well as in June and July. And that's because when the waters there are warm during the spring and early summer, that tends to basically cause a weaker subtropical high pressure system. The winds blowing around that high pressure system tend to also be weaker, causing less mixing and churning up of the ocean surface, which leads to additional warming of the tropical Atlantic. So the tropical Atlantic warming up faster than you would see in a normal Atlantic hurricane season. And so we have these various precursor signals, and I'll talk with you more about some of the precursor signals that we use specifically with our early August outlook here in just a minute. One thing I do want to point out is that while our August 1st is 2 months into the hurricane season, over 95% of your major hurricane activity occurs after the 1st of August in a typical Atlantic hurricane season. So we still have a long way to go, even though calendar-wise, we're probably pushing 40% of the season. We still have over 90% historically of hurricane activity left to go. The average first Atlantic hurricane actually forms tomorrow, August 11th. And then we can see for August through October, so the peak of the season, you can see a very well-developed La Nina, so colder than normal water in the eastern and central tropical Pacific, and a lot of warm water in the tropical Atlantic, which makes sense since hurricanes live off of warm ocean water, so that's more fuel for developing storms. So now to step in and talk more about the 2022 outlook in detail. Just as a reminder, that these are the final numbers that we came out with: 18 storms, 8 hurricanes, and 4 major hurricanes. The early August outlook is our final seasonal outlook for the 2022 season. The next product that we put out, so during the hurricane season, we do put out 2-week forecasts. So we try to predict basically how busy the next 2 weeks are going to be. We put out our first one of those with the seasonal outlook on the 4th of August, and then we'll issue updates on the 18th of August and every 2 weeks following, until we get to the middle of October. And the reason that we do that is because you can have above normal hurricane seasons, but quiet periods during those seasons. And alternatively, you can have an extremely busy season like 2020, and still have fairly quiet periods like we had in late September of that year. It got very quiet there for about 10 days. And then obviously all hell broke loose once we got into early October in 2020. So now what I want to do is take a look at what we currently have going on. So here are current sea surface temperature anomalies or differences from the long-term average. The blue rectangle highlights the eastern and central tropical Pacific. You can see a lot of blues, especially in the central tropical Pacific, indicative of a very robust La Nina event. If we look in the Atlantic, we do see some oranges and reds indicating warmer than normal waters in general across most of the tropical Atlantic. We do see some cooler water in the subtropical Atlantic, and that's one of the reasons why we lowered our forecast a bit. When the waters there are cooler than normal, that can sometimes lead to basically kind of increase in frontal activity because the subtropics are a little cooler, the tropics are a little bit warmer, and sometimes that can actually lead to increased frontal intrusions into the tropics, potentially causing increases in levels of shear, which may counteract some of the reduction in vertical shear that we typically observe with a La Nina. We do have a very robust La Nina event in place right now, and we do expect this to continue and perhaps even get somewhat cooler. The official forecast from NOAA gave it a little over 60% chance of La Nina for August to October. I would say that's probably, we can say now because it's a month later, we say it's probably about 90% chance of La Nina for the next few months. So I certainly think pretty much La Nina is in the bag for the rest of the hurricane season. We're going to have a pretty healthy La Nina event in place, and I'll try to convince you of that here in the next couple of slides. Here's a forecast from a variety of different global models for August through October. If you like acronyms, this is a slide for you. You can see all these different models and all these different acronyms. I don't know if there's anybody in the world who can tell you what every single one of these acronyms means, but there's a variety of different statistical models which use techniques basically kind of using like what we do for seasonal hurricane prediction, where you basically try to basically use the past to predict the future. There's also dynamical models, which basically use the full physics of the atmosphere ocean system and basically run those forward in time. And with El Nino and La Nina, the statistical models do almost as well as the dynamical models because there are still some real challenges of trying to be able to forecast this. But during the summer, the forecasts typically are fairly good. And so we would expect, again, probably a La Nina for the next several months. And one of the reasons why is you had very, very strong winds blowing across the eastern and central tropical Pacific has caused a lot of mixing, a lot of churning up of the ocean surface, a lot of cooling. And we've actually generated what's known as an oceanic Kelvin wave, which basically is an ocean wave that moves eastward at about 5 meters per second. And basically, as it does so, it's bringing cooler water. You can see that propagation from the central Pacific closer to the eastern Pacific. And these are very cold anomalies. It's almost maxing out the color scale in this buoy data. Likewise, here's an animation showing. This is a plot showing on the y-axis. We have the depth of the ocean. So the top of the plot is the ocean surface. and then it's a longitude spread across from the Western Pacific to the Eastern Pacific. And you can see, if you look at the, say, top 50 meters of the ocean, you can see, there was a little warmth, but most of that is gone with that oceanic upwelling Kelvin wave. So we do expect to see continued oceanic cooling in the Eastern and Central Tropical Pacific over the next several weeks. We also do see the models are forecasting a very strong signal for continued strong trade winds, which should help kind of reinforce this La Nina for the rest of the Atlantic hurricane season. So I'd say, honestly, I'm more confident that La Nina is going to persist than I am necessarily at the exact amount of activity we're going to see for this hurricane season. Now stepping ahead and looking at what we have currently in the Atlantic Ocean. So here, again, reds and yellows indicate warmer than normal water. Blues indicate colder than normal water. If we just look at a box from, say, the west coast of Africa to the islands, the Leeward and Windward Islands, the Lesser Antilles, that box is actually quite warm over the last month or so. It's the 6th warmest on record. Back to the early 1980s. So from that perspective, we would expect to see, quite a healthy Atlantic hurricane season. Again, that cooler water in the subtropics is not typically what is associated with an above normal hurricane season. However, if the tropical Atlantic is quite warm, you can still see very busy seasons, even with that coolness in the subtropical Atlantic. It's certainly not a deal breaker. So right now, that was one of the reasons why we hedged our forecast a bit in early August, but we still do anticipate an above normal hurricane season. So what I'm going to show you in this next plot is basically historically what water temperatures in August have correlated with Atlantic overall hurricane activity. So basically, as measured by accumulated cyclone energy. So here, darker colors indicate stronger correlation. So basically, these are the regions, if you're looking for an active season, that you want the waters to be warmer. And so if we toggle back and forth, you can see the tropical Atlantic warming is associated with the busy season. The subtropical Atlantic, that typically in a busy season is a little bit warmer than normal as well. So that would argue overall for a little bit less activity, which again is one of the reasons why we lowered our forecast. And so we use a variety of different techniques to come up with our forecast. I think with this particular outlook, we had 6 different numerical outputs. And so one of the big ones that we've been using for the last few years is an August prediction model that uses July large-scale conditions. And so these 3 predictors on average can explain a considerable amount of the variability. So we're basically assessing conditions in the tropical Atlantic, in the subtropical Atlantic, again, the water temperatures, when those are cooler than normal, being a negative for a busy season, so being a positive for those living along the coast. And then we have a predictor over Africa where we're assessing the strength of the upper level winds. When those are stronger out of the east, that indicate a very strong tropical easterly jet, which is typically associated with a busier Atlantic hurricane season. And so these 3 predictors in combination have done quite well at explaining levels of variability. Going back to the early 1980s, we started in 1982 with this analysis because that's when our high resolution sea surface temperature data starts. However, one challenge that you can have when you use a monthly average is that there's also, in addition to El Nino and variability on a seasonal timescale, we also have variability on a subseasonal timescale. So variability on, say, a 1 to 2 month timescale driven by a phenomenon known as the Madden-Julian oscillation. And that's basically thunderstorm activity that propagates around the globe about every 30 to 70 days. Sometimes it's super robust, other times not as much. But if you get a robust pulse of this Madden-Julian oscillation, it can make the large scale look either more or less necessarily conducive for Atlantic hurricanes on a shorter time scale that may not be representative of what you're looking at on a seasonal time scale. So in regards to that, what we then did was we created a different model, a very similar locations, but using 50-day averages. So this would basically encompass, since it was issued in the early August, it would basically encompass from June the 12th to July 31st. So those predictors average over a 50-day period. And so the model over 30 days generally won't call for about an average season, whereas the model average over 50 days called for a busier season. And I think one of the reasons, again, why we saw the why the July forecast, just using the 30-day averages, was a little bit lower was because we had generally basically subseasonal variability in early July that really ramped up your shear. And that, I think, was not necessarily representative of the longer term. So here we're trying to use a 50-day average to be more representative of the longer term signal. Now, we could use a 2-month average, but honestly, it seems like it's about mid-June when the tropical Atlantic really kind of locks into the climate that it's going to be in for the hurricane season. And so this model we built from 1979 to 2021. And again, you can see very similar levels of skill to what we got with our 31-day model using just July averages. We also use statistical dynamical models. So in this analysis, what we're doing is we're using model forecasts of August and September sea surface temperature and wind shear. So when the models forecast above normal waters, lower than normal shear, that tends to be associated with a busier overall Atlantic hurricane season. And these models can do a reasonably good job of forecasting sea surface temperatures and wind shear. And so for example, in this case, we use 3 different models. We use the European Center for Medium Range Weather Forecasts, or ECMWF model. We use forecasts from the UK Met Office model, and we use forecasts from the Japan Meteorological Agency model. And all 3 of these models do show good levels of skill. And so these climate models are also, they use the field physics of the ocean and atmosphere, but then they actually will run hindcasts. So basically saying how well did these models do at forecasting previous seasons? Because they want to make sure, obviously, if you have a climate model and you're trying to forecast, temperature and winds and, water temperatures and things like that, you want to make sure it has worked well, because in the case of a climate model, unlike your stock portfolio, past performance is usually a guarantee of future results. If the model stinks on past data, it's probably not going to do well on future data either. And so we use these 3 different models, and here's just an example of the visualization from the European Center model. So again, it's not perfect, and you can see ECMWF, the red line, has certainly been below the blue line the past few years, and that's because the model in general the last few years has had a bias more towards El Nino than what we've actually observed. This year, the model is certainly not calling for El Nino, so I think the forecasts are quite reasonable. And so overall, the European Center model, the UK Met Office model, the JMA model, all of these ones forecast levels of activity very similar to what we came out with as our final forecast. We also use analogs, which involves going back into the past or looking for years in the past that had conditions most similar to what we currently see and what we expect to see for the peak of the season. And so when we select analogs, we're looking at kind of the large scale ocean atmosphere. We're not saying, say, for example, 2021, last year is an analog. We're not saying Hurricane Ida is a guarantee in 2022. We're just saying overall the large scale environment looks fairly similar to those 4 years. And you can see overall the levels of activity in those 4 years is very similar to what we're forecasting in 2022. Now, if we look at this plot, we can look at sea surface temperature anomalies in our analog years. So our analogs, one of the big things we're looking at is La Nina. We're basically forecasting continuation of La Nina conditions for the remainder of the hurricane season. We're looking for years where the water temperatures in the Atlantic were near average. And actually, you can see that we're actually slightly cooler than average in these 4 years. Perhaps the water temperatures will be a little bit warmer than that in 2022, which is one of the reasons why our forecast is a little bit higher than the average of our 4 analog years. But overall, our final forecast is quite in line with the various model outputs that we have. But with these forecasts, obviously there is uncertainty. So we've calculated the uncertainty associated with these predictions. So with our forecast, you hear one number, and that's our best estimate. And I think to the general public and to the media, giving them one number kind of helps them focus on what your best guess is. But there obviously is uncertainty associated with those forecasts. So using the historical error of our predictions, we can calculate uncertainty ranges. And these uncertainty ranges are quite close to what you would see with a forecast, say a seasonal forecast issued by NOAA. So for example, we're forecasting the best estimate is 8 hurricanes, but the range is 6 to 10 hurricanes. We also do probabilities of landfall, and certainly you can't say months in advance when or where storms are going to strike. And you can certainly have a nasty hurricane in an otherwise very quiet season, like Hurricane Alicia in 1983, a year with only 4 overall named storms. But in general, more active seasons do have more landfalling hurricanes. And so what we've calculated here are probabilities. So on the right-hand side, these are the probabilities based on historical data. And on the left are the probabilities for 2022, for the rest of 2022, again, because we're predicting overall an above normal Atlantic hurricane season. And so you can see the probabilities are elevated. So for the entire US coast, the probability of one or more major hurricanes hitting it this year is about 70%. On average, it's about 50%. So you can see the probabilities are somewhat elevated this year. We also have probabilities all the way down to the county and parish level, where we again are calculating historical probabilities and then adjusting them based on our forecast. And so what we want to do is, what we do here is we count all the storms that track within 50 miles of each county or parish, as well as each coastal state. And the reason that we use a 50-mile buffer is because, whether a storm hits your county or the county next to you, obviously, if a storm makes landfall right next to your county, you're likely also to be very significantly impacted. So this kind of helps expand the sample size and kind of get rid of some of the volatility that you have. Because obviously here we're using 141 years of historical hurricane tracks, which is great, but obviously, it's still a fairly limited sample size when you get down to the county level. So by including that 50-mile buffer, kind of helps to smooth out some of the noise. So in this case, we're looking at the 50 miles within 50 miles of landfall in Plymouth County, Massachusetts. And Plymouth County I selected because there's not a ton of storms, so it's good for visualization. It's also the county I grew up in. So you can see, for example, in this case, in 141 years, you've had 10 hurricanes tracked within 50 miles of Plymouth County. We also have these probabilities at the individual state level. So you can see the various states listed here. We have it for every state from Texas to Maine, but here I just wanted to give you a few examples without having you have to strain your eyes too much. So for example, you can see Florida, probability of a hurricane within 50 miles of Florida on average is a little over 50%. This year it's at 72%. And one of the things that we point out is that, a state, say like Florida, that has a huge coastline, if you say get a hurricane making landfall near Miami, Pensacola may have very few or if any impacts, whereas if a storm makes landfall on the Mississippi coast, the entire coast of Mississippi is probably going to have some impacts because obviously the coastline of Mississippi is much shorter. So please take that into account when looking at these probabilities. We also have probabilities for every coastal state in Mexico, all the coastal provinces of Canada, and then also various islands and countries in Central America and the Caribbean. Now, if you can't get enough seasonal forecasting, I invite you to check out seasonalhurricanepredictions.org. We have almost 30 groups now submitting seasonal hurricane forecasts to this website. They include private sector weather companies, government agencies, as well as universities. So on this website, we have an extensive amount of information on the different forecast methods, which group is using what, links to the different forecasts. And then also we have visualizations. And so I'll step you through this plot. So here on the left, on the y-axis on the left, the red dot represents the observed values to date. So obviously no hurricanes yet. The orange dot represents the average of all the different forecasts. And the forecasts are displayed with dots if there's no range provided. If there is a range provided, you can see the forecast ranges displayed. And they're also color coded, where purples represent government, or purples represent private sector weather companies, blues represent universities, and red represents government agencies. You can see in general, most groups are forecasting a slightly above normal hurricane season this year. And this website is actually about to get a good upgrade in the next few weeks. Or I think maybe the next couple of months. So certainly stay tuned for that. Certainly by next year, there'll be an upgraded website with some additional visualizations and some other new products I think that you will like as well. And then just kind of to finish off, I do want to talk a little bit about, what the heck's going on? I've been getting a lot of questions, a lot of people getting antsy, what the heck is going on? It's been a quiet season. We had Alex really early on, then we had a couple of storms in pretty rapid succession with Bonnie and Colin. And then, since then it's been crickets. You had nothing. Bill mentioned there was an area that they're monitoring right now, but the short-term future isn't great and the long-term future is even more bleak for that system. So it doesn't look like, if that system forms, it's going to be very short-lived, extremely unlikely to become a hurricane. So, we are going to getting to the point where, you do expect to see this season starting to ramp up. So here's the seasonal cycle. This is a great new graphic that the Hurricane Center's just debuted. So here you can see reds are hurricanes and tropical storms, yellows are just the hurricanes. And you can see, kind of through about August 10th, it's not super busy. And then you see a big spike with the climatological peak of the season being around September 10th. But you kind of see a big ramp up about August 20th. And so Dr. Bill Gray every year used to ring a bell on August the 20th, signaling the active part of the Atlantic hurricane season. About 85% of all your accumulated cyclone energy, so an integrated storm metric, as well as your hurricane activity occurs after August 20th. So, really think we would expect to see things starting to ramp up here fairly quickly, given our outlook. However, there are a few other things going on. There's kind of the seasonal drivers that we talked about. There's also things going on subseasonally. And so as Bill mentioned earlier, he gave me a lot of great great talking points to start off with. Here's a look at the, it's been dusty, it's been dry, and that's pretty typical early in the season, but it's been a bit drier even than normal. So I think that's one of the reasons why we haven't seen, really anything over the past few weeks. The vertical wind shear, that change in wind direction with height, really hasn't been, it's been about average, maybe even a little bit weaker than average overall since early July. But it's been more the dust and dry air, I think, that's been holding things back. And that seems like it actually may be something that happens fairly often in these robust La Nina years like we currently have. If we look back at some of the strong La Nina years like 1998, 1999, even 1950, those fairly robust La Nina years can actually start fairly late and still have quite a bit of overall storm activity. So if we look, this is a plot showing basically upper level vertical motion forecast coming up. And so if we look at this plot, here reds indicate air sinking, blues indicate air going up, and the time is progressing downward. So the top of the plot is basically today, and the bottom of the plot being the 25th of August, so over the next basically 2 weeks. You can see the reds getting darker over the Pacific, the blues getting darker over Africa and the Indian Ocean. And when you have that kind of a pattern where you have air going up over Africa, air sinking over the Pacific Ocean, what that tends to result in is upper level winds blowing out of the east in the Atlantic in an anomalous sense. So that means reduced levels of vertical shear at both the forecast from days 6 to 10, as well as days 11 to 15. So this kind of a pattern typically is associated with quite robust periods for Atlantic hurricane activity. So right now, as Bill noted, Africa looks kind of anemic at best, but it does look like Africa should start to pick up and start to generate some more robust easterly waves here in the next 5 to 10 days. The forecast levels of vertical wind shear, especially in the eastern Atlantic, coming up are also fairly low. So here blues indicate reduced levels of shear. So I do think things will turn around. As Bill showed, there's not a ton of signal in the model guidance as of yet, but I have seen this happen in the past too, where the models will forecast kind of the pattern changing, and they'll forecast that before they actually start spinning up the tropical cyclones. So here is a look at the 15-day ensemble. So this is 51 different forecast members, tropical cyclone tracks, and you don't see a lot of blues and reds. So right now the models don't really have a ton of signal near the ECMWF or the global forecast system from the U.S. government. This one's maybe a little more robust, potentially hinting at some storm activity coming off late during the period. So I do think, if we watch these and look at these 3, 4, 5 days from now, I do expect to see some sort of pickup in this signal as the overall large-scale environment does become more conducive for these storms. The bell rings on August 20th, and we've certainly seen this. I remember even in 2017, the season was kind of limping along, not a lot of activity. And about August 20th, the bell rang, and Harvey had formed, and it kind of weakened in the Eastern Caribbean, and then it re-intensified shortly thereafter, and obviously then pretty much all hell broke loose for the next month. Certainly not saying we're looking at another 2017 September, but things can look fairly quiet at this point in August, and things can then really turn around. So overall, I would say, given the fact we have a very robust La Nina combined with a relatively warm Atlantic, we do expect to still see a healthy rest of the Atlantic hurricane season, with the obvious caveat being, again, with these forecasts, past performance is usually a guarantee of future results, but the atmosphere-ocean system does have a way of keeping us humble. So we shall see when we revisit this the next time how these seasonal forecasts are tracking. So with that, I'd like to thank you very much for your attention. And here's my contact info, and now we'll try to answer any questions.
All right, you may want to unshare your screen.
Yep, and That was fantastic. I think Tim has a few words to say, and then we'll get back with the questions.
Absolutely. Gosh, that was good. I'm still on slide number 4, I think, trying to catch up. That was terrific. So thank you. Thank you, Phil. Yeah, we just want to once again say thank you to USAA and the South Potawatomi Convention and Visitors Bureau, just making these presentations a possibility so we can share all this with you. So a lot of other sponsors as well, but those are the big two. And Weather Boy, Port of Brownsville, Visit Brownsville, Black Magic Design, all those folks, Walmart, all part of what we're doing. So thanks to all of them. We got a bunch of questions coming in online as well. So I'll give it back to Bill and to Hal, and then we'll get to those online questions in just a little bit. Bill, go ahead.
Cool. I was looking at I was intrigued by the cooler weather, or cooler sea surface temperatures in the subtropics up to off of Europe. I wonder, do you think that could be contributing to a somewhat stronger than normal subtropical high, which would increase the gradient and therefore the wind across the Western Sahara that may actually have a role in the dust being more than usual?
Yeah, and I think some people are asking too about like the European heat wave and how that might be playing a role. And if you look at the circulation, basically where the highs and lows were positioned, effectively that big high pressure, the circulation effectively ended up with anomalous northerly flow during the month of July. Because if you look back, say in June, we didn't have that cold blob in the subtropics, and so. Yeah, I mean, I think that may be one of the reasons. And so that's one of the big things that we're kind of monitoring to see kind of exactly how that transpires, how much of an impact that then plays the rest of the season. There's been years where that's, I think, played a big role. And there's been other years like 2010 where the subtropics were a little bit cool and the tropics were extremely warm and it didn't really matter at all. So that's kind of one of the big things we're going to be watching going forward. But certainly if for some reason this forecast does bust, that's we're certainly going to be blaming it on. We have a very robust La Nina and the deep tropics are quite warm. And the forecast wind patterns coming up would indicate that the tropical Atlantic should continue to, obviously every year it warms up during the summer, but should warm up at a faster rate than normal because the winds forecast over the tropical Atlantic look to be quite weak over the next couple of weeks. And when those winds are weaker, that allows more anomalous warming, especially if you don't have tropical cyclones churning up the water and cooling it off, that can really feed to some additional warming. So we'll see kind of, how this transpires. But again, I think what I've seen in the past is that sometimes the models will be on to the large scale changes, and then but the models won't show necessarily a lot of storm formation. And suddenly you go to bed one night and look at the ensembles the next morning, and suddenly there's a storm there. So we'll see. Yeah,
I was intrigued. Also, your analog year showed the subtropical waters running somewhat cooler than normal. Do you look at the verification of the forecasts in those analog years to see if there was a bias or a trend during those years to formulate your forecast?
Yeah, so we verify all of our forecasts every year. I don't specifically separate out, I separate out the statistical model and look at how that one verifies, but I don't actually separate out the analog. But usually the average of the analog years is very, very similar to what we forecast. So if you look at, if you look at, say, a year like we royally busted like 2013, our analogs for 2013 were fairly busy. We didn't have quiet years and just say we ignored those analogs. But yeah, I mean, that's one of the reasons why we picked the analogs that we did was because in general, we're trying to find years where the subtropical Atlantic was a little bit cooler to try to kind of, basically see kind of how that all worked out. One of the challenges is that, we're in the third year of a La Nina and there's not a lot of those. And also the Atlantic's a lot warmer now than it was, say, in like the 50s and 60s. So it's hard to find a ton of really good analogs. And so there's never obviously been a year exactly like 2022, but some years match up fairly well, but like 2021, I would say in April or especially in June was a pretty good match. Whereas now I think it's slightly less good of a match because the tropical Atlantic is warmer now than it was in 2021, but the subtropics is a little bit cooler. So, and obviously 2021 had a big break between Elsa and Fred, but then the season picked up and we had Fred, I believe, formed, I think today or yesterday in 2021. So it's definitely a longer quiet period. But again, I don't put a ton of stock in that unless, if we were talking 2 weeks from now and it's still quiet and the models still have nothing, then you'd be talking a whole different ballgame.
Yeah, I understand. Yeah, analogs, there's a lot of caveats in that. There's just way too many moving parts to capture something exactly alike.
Correct. Yeah. And I mean, if I pick analogs and I have my colleagues that do season forecasting pick analogs, we'll probably have a couple of years that we agree on, and there'll be other years that we don't, because everybody's looking at something a little different. And so, yeah, I mean, in general, my analogs in June and July are probably going to be fairly similar to what I select in August, but you will see years come in and drop out depending on kind of how we see things change from month to month.
Yeah. Speaking of the three-peat we're having on La Nina, has there ever been a fourth year in a row of La Nina?
Not that, I mean, depending on which index, no. There's certainly been years where you've had 4 years in a row with no El Ninos, but to go like through 4, and I mean, it depends too, because while we say it's a 3-year La Nina, there have been a couple of months where the official NOAA threshold of La Nina has not been met during that time. I mean, I think right now we're in a really robust La Nina. You're talking, depending on which index you use, there haven't been too many this cold in the month of August. So for example, right now, the Nino 3.4 region, which is the central and eastern part of the tropical Pacific, is -1 degree Celsius, which doesn't seem like much. I mean, obviously, if you change the temperature 2 degrees Fahrenheit, you're probably not going to notice much. Maybe if the dew point dropped from 77 to 75, you might notice a little less humid. But those small changes make big differences in the atmospheric circulation response. And so, if you look at the current atmospheric circulation response, in a lot of ways, it is some very classic La Nina, but there's also been kind of some fairly robust subseasonal activity, I think, which has kind of really helped enhance the Eastern Pacific activity beyond what we normally expect in a La Nina. But with that being said, the Western Pacific, so typhoon season has been extremely quiet. Since mid-April, we've had the lowest accumulated cyclone energy in the Western North Pacific on record. So from that, which is a classic strong La Nina signal, a very weak monsoon trough, and really not much going on there. So yeah, I mean, I think, again, it's interesting doing these talks, and I'm glad these things are recorded, because it'll be interesting watching my hand waving and discussing now, and we'll see how, 3 months from now, if I'm saying I can't believe I was that neurotic about it, or, what the heck were we looking at earlier? Or we completely missed, a dud of a hurricane season.
Well, speaking of hand waving, I'm going to hand wave off to Hal and then Tim to hit you with some questions.
No, excellent presentation, Phil. I had a question. You mentioned Dr. Gray ringing the bell on August 20th. I heard a rumor that donuts may have been involved with this ceremony. Is this true? Could you expand that?
Yes. So donuts were not usually donuts. So Bill Gray was a huge fan of donuts, as am I. And so every hurricane forecast, so starting back in like the mid 1980s, before we had internet, basically Dr. Gray used to mail out forecasts to everyone who was interested. And so it basically became like this massive envelope stuffing party. And so we always brought in donuts. And even when we switched from, we put everything online and all that, there were always still donuts with forecast day. So we do continue the forecast day donut tradition. It's been going on every year. I think it's about 1988. It's a little bit unclear exactly when the first box of donuts came with the forecast, but I don't believe he actually had a donut on bell ringing day, but certainly that would not be a bad tradition to continue. I mean, any excuse to eat donuts is fine by me.
It sounds like it was more of a forecast day as opposed to a bell ringing day. Now we have clarification. I've wondered this for a long time.
Yes. But yeah, no, he and so outside Dr. Gray's former office, there's actually like a glassed-in enclosure with like some memorabilia from Dr. Gray's office, and in that glassed-in enclosure is a bell, is the bell. So it's there for it's preserved for posterity.
So I had a question. We saw a few satellite images of these. Of this deep convection in Africa, and these become tropical waves. Do these get counted, like these big clusters of thunderstorms coming off the coast of Africa, or even what's going on inside Africa? Are there statistics on that? Are there counts on that? Is it possible that we'd get a strong La Nina, warm tropical waters in the Atlantic, but then just not have many of these clusters of thunderstorms compared to other years?
Yeah, I mean, so, and this goes back to work like Bill Frank did back even in like the 60s. And so the number of waves coming off Africa seems to be fairly constant, about 60 to 70 per year. But the latitude that they move off the coast varies. So if it's too far south or too far north, you have to have kind of in a sweet spot. And another big thing is the waves some years are just not as robust. So you'll get some waves that are just kind of anemic. And so a strong easterly wave does not guarantee that it's going to develop, but it does help. So for example, in those plots I showed right at the end, by that, the forecast large scale circulation basically enhancing vertical motion over Africa, that will very likely help to amp up those waves. And then if those waves are more vigorous, likely increase their chances of forming, especially if you have those more vigorous waves moving out into an environment of fairly low shear. And if you look at the forecast shear for 10 to 15 days from now across the Atlantic, it's pretty much from Africa all the way to the US, it's just very low. So that theoretically with that in a wave, you should actually get something forming. But again, there's sometimes things, this system that was out there currently was in a very low shear environment for several days, wasn't super dry around it, and it didn't go for whatever reason. And trying to forecast storm genesis, as I'm sure Bill Reed can talk, is a real challenge.
Phil, you also mentioned, you showed a map of the Saharan air layer. Was that a map of the anomalies, or was that just a snapshot of one day in time? I mean, a little bit about that map and how the Saharan air layer is monitored. I mean, can we look at anomalies of dry air or Saharan air over time? How do we look at that?
Yeah, so that was just a snapshot, just to give you an idea of how much dust can be out there at any particular time. And so we've done some work looking at the Saharan air layer and kind of how it relates overall to Atlantic hurricane activity. And so in general, what we find is that the amount of dust, so when you get vigorous waves moving off the coast of Africa, those easterly waves or thunderstorm complexes, they generally bring dust off with them. So just because you have dust in the eastern Atlantic doesn't necessarily mean that's a quote unquote bad thing for hurricane season. 2020 is a great example. We had a super strong dust outbreak in late June that year. And obviously 2020 was an extremely busy season. What we found though is that if you get a lot of dust basically moving farther west into the Caribbean, that is typically a sign of a quieter Atlantic hurricane season, because associated with that dust is dry air, but also if the dust is going all the way to the Caribbean, it tends to be a pretty strong low and mid-level easterly winds, which means more shear, and basically just means overall an environment that's less conducive for Atlantic hurricane activity. So when it comes to monitoring the dust, there's not a lot. I don't know if there's any anomalous dust products, but what you can do is you can look the Cooperative Institute for Research in the Atmosphere, or CIRA, which is based next to our department at CSU. They have some nice products where you can monitor the kind of the instability in the atmosphere and the basically brightness temperatures of clouds. So when you have intense thunderstorms, those clouds go up higher in the atmosphere, so they go up to lower temperatures, because as you go up in the atmosphere, the temperatures cool. So if you look at, say, the last couple of months, those brightness temperatures have been warmer than normal, which is indicative that the convection or the deep thunderstorm activity has been rather anemic. Now, again, with the forecast pattern shift and potentially kind of locking into that more La Nina-like pattern, we would expect that kind of dry, stable conditions should start to diminish. And that's kind of even climatologically, that's one of the reasons why the season is usually quiet in June, July, and early August. It's not that there's too much shear, it's just the thermodynamics. So the waters aren't necessarily warm enough, and it's fairly dry and stable. And about September 10th is kind of the perfect intersection of shear, when it's still relatively low, and there's still being enough moisture, because the moisture, the instability tends to basically get more conducive even later into September, but the shear starts to ramp up. And so, especially with La Nina in general, La Nina keeps your shear lower longer. So in a La Nina year, you get more robust late seasons. For example, late September of 1998, we had 4 hurricanes in the Atlantic at once, which is extremely impressive, because the Atlantic's a small basin. So to even drop 4 hurricanes where they're not shearing each other off was quite impressive. So again, we do expect, an above normal season, and we do expect kind of this dry air and dust stuff to be ameliorated here in the next few weeks. But certainly I think that's been one of the big things that's been holding things back, because the shear so far has been near normal, maybe even a little bit lower than normal.
Thanks, Phil. You explained that really well. I want to pass it over to Tim to see if any questions came in from online.
We do have some good questions coming in online, and Dr. Phil, you referred to Bill Gray as a walking encyclopedia. I'm going to say you're volume 2 of that encyclopedia, just with your background knowledge of all this stuff and how you're able to bring things back to light. One of our loyalists is Casper, who always has some great questions, and he's been waiting all week to ask this question. So let me just read it off the screen for you because he wants to try to stump you. Okay, he says, with the unprecedented amounts of injected stratospheric water vapor from the Hunga volcanic eruption, how will that event impact global tropical cyclone development? And he wants to stump you on that. So have at it.
Yeah, I mean, so, with these various volcanic eruptions that happen, most of them, so they have to happen in the tropics for it to actually kind of get into the overall. If they happen in the extratropics, it basically tends to fall out pretty quickly. So we have that huge volcanic eruption in Iceland that from the volcano that I don't know, maybe like 8 people in the world can actually pronounce. That the volcano starts with an E. And so like you get these big volcanic eruptions in the subtropics or mid-latitudes, and those don't tend to necessarily cause too many issues. In the tropics, we had that, was it La Soufriere or whatever last year? You do get those, but in general, they don't necessarily inject enough volcanic ash high enough to cause significant modulations of global temperature. In the case of, say, like Mount Pinatubo, which is kind of the last one that had big impacts on global temperature, if you inject enough volcanic ash high up, that can basically cause a temporary global cooling because you're basically blocking incoming solar radiation. And that can take, in the case of Pinatubo, 24, 36 months to really kind of to basically all that kind of fall out and get mixed out. Because once it gets up into the stratosphere, it's a lot more stable and it's a lot harder to kind of mix it and get rid of it than it is in the troposphere. Lower down in the atmosphere, effectively will just rain out.
And he follows up with a question about the underwater eruptions. Does that impact water temperatures and the waves and stuff in the equatorial regions?
Yeah, I mean, I would think it would do it on short-term timescales, but in terms of like longer-term stuff, we haven't really seen very much in terms of its impacts. But obviously, on short-term timescales, an underwater eruption is going to cause all sorts of issues. But a lot of times, too, I'm not necessarily sure how much of that actually makes it all the way up to the surface. And
one other question. This isn't from Casper. This is another question. Has a hurricane ever caused postponement or delay of a Boston Red Sox baseball game? At Fenway Park.
I have to go back. I know Hurricane Bob certainly would have in 1991. It canceled the Marshfield Fair, which is where I was going to be going the day that it happened. So I didn't get my fried dough, and I'm still not happy about that. But I believe also, I want to say 1961, there was Esther, and I did a kind of a loop off the East Coast or south of Massachusetts, and I think JFK was in the area and it caused issues with his flight as well in Massachusetts. But I'm sure there have been games that have been canceled. Honestly, probably more recently, it would be rainfall from kind of these extratropical, basically these storms kind of transitioning from tropical to extratropical, but I'm sure there have been cases. Now, I thought you were going to ask about Rockies games in Colorado.
Well, the same question applies, yeah.
Yeah, but I think honestly what's been really interesting this year is some of these monsoonal surges we've seen in the Southwest, you can actually see the moisture actually being basically ejected or brought up from remnants of eastern tropical Pacific cyclones. So those actually can amplify out the Southwest monsoon. So every now and then you can actually say in Colorado that you're not getting a hurricane, but you're getting moisture from remnants of a tropical cyclone. So that's about as close as we get in Colorado. But Bill Gray used to always say the reason we forecast hurricanes in Colorado is because the storm surge can't get you at 5,000 feet.
We hope, my goodness, we hope. Hey, we've got information from the network programmers to go a little bit long today if we need to. So Bill, if you've still got some questions, Bill, Hallie, the one, jump back in by all means.
Yeah, I was following up on the Colorado. So if you can forecast it, tell them that there's tropical air coming in there. The bars can run specials on those fancy rum drinks with the umbrellas in them.
That's right.
I had back to the more mundane but serious stuff. I remember the first time I got educated by Dr. Gray in a seminar on his technique that he emphasized that it was only accounting for the storms that formed from the waves coming across off Africa. The hybrid or storms that form off old fronts or old clusters of thunderstorms like Alicia don't fit the model he used. Have you been able to tune it to where it accounts for those now, or is that still a problem?
Yeah, not really. And that's because kind of at the end of the day, we're not really forecasting hurricanes. What we're forecasting is a large scale environment. So if the shear is low, the waters are warm, there's enough moisture, we should have more storms. But there is variability. Even if you have low shear, a lot of moisture, the waters are warm, you can see it's not a one-to-one correspondence. And so basically, storms that form off of Africa, storms that form in the Caribbean are generally the lion's share of your major hurricanes or the lion's share of this accumulated cyclone energy metric. But if you say were to subtract out these storms that form from, weird from fronts, higher latitude stuff, you would actually get higher levels of skill for the forecast, just because I think those are just more, they're not really predictable on a seasonal timescale. I think that's more just quote unquote almost noise. It's just, whether a trailing front happens to spin into the drag, it's basically spinning a front kind of drags into the Gulf of Mexico, and you just get some little vorticity center that spins off of that. I don't know. That's really, really hard. And those storms tend often to be fairly marginal and weak. Obviously, in the case of Alicia, not marginal and weak, but, it was basically here today, gone tomorrow. It formed and was, on land really quick. And so those are hard to forecast on a seasonal timescale. And frankly, something like Alicia, I'd be curious to see if you gave today's, vastly improved model guidance, a week before Alicia, would the models have gotten Alicia? I'd be curious. My guess is maybe not. I don't know. I'd be curious to try.
Yeah, exactly. You rarely see a model cane forming along the Gulf Coast or in the subtropics off the East Coast.
So those are
not like the ones you see down in the Caribbean or off in the Atlantic sometimes.
Yeah, I mean, obviously it was super weak, but Colin's a great case in point. The thing kind of came up out of nowhere. And so, often there are like Colin where it's here today, gone tomorrow, not much of an issue. But those storms, they'll often pinpoint maybe a few days in advance, but they don't necessarily have the long-term skill. I mean, sometimes with these systems coming off Africa, you can have a storm, for example, like last year with Hurricane Larry, where the European model was onto that sucker before it had even developed over Ethiopia. Like 2 weeks out, it had this monster signal that we were going to get a major hurricane. And it was there and it formed. And it was like, too bad we can't do it with every storm. But you can get these huge signals. Then you get another storm like Sam, which was another major hurricane. The models were all over the place. One run, they're saying yes. Next run, they're saying no. Even the ensembles were here or there, gone all over the place. And so there's still a lot of uncertainty. And I think, from an interesting research perspective, would be to try to figure out, like, have Larry and have Sam, two storms that kind of formed in the same place, both became long-lived major hurricanes. Why was the one so much easier to predict than the other, and to kind of run through that? But yeah, there's definitely challenges. So I certainly look at I have way too many bookmarks. I spend way too much of my time looking at models. But there's definitely still challenges with that. And one thing I do want to point out is that, normally as a guy, if you tell your wife you're looking at models, they're not usually too keen on that. But, when you're a meteorologist, you can tell your wife you're up at night looking at models, and she's okay with it.
I don't know, though. As meteorologists, we probably have that same lusty glare when we see a massive storm on the models.
Exactly. Yes. Well, I've always been used to me having women and, various other women in my life, like, in 2017, like Irma and Maria and things like that. So, yeah.
The last question I have is a specific forecast question. I need to know what the threat of a hurricane or a post-tropical system is in Atlantic Canada, September 10th through the 16th.
Okay. Relatively low. I mean, it is kind of close to the climatological peak for those recurving cyclones. If you look at Atlantic provinces of Canada, I mean, we have probabilities for them, but then you have probabilities of like hurricanes, and oftentimes they are becoming extratropical. So these storms, they form off Africa, they move north. As they start moving further north, the waters are cooler. There's often interacting with fronts that are in the middle latitudes. And so these storms may not actually be called hurricanes anymore. They may be post-tropical, but they still can cause, pretty significant impacts up into the Atlantic provinces of Canada. You can get robust hurricanes like like Igor in 2010 that slammed up into Newfoundland, or Juan in 2003, which caused a lot of damage in Nova Scotia. But often they are kind of, quote unquote, on their way out as tropical cyclones, but still can cause pretty significant impacts. So the wind field gets really broad. So I would say Atlantic provinces of Canada, the entire provinces of Canada, hurricane force winds, probability for a week would be like 2 or 3%.
Yeah, I'll still pack the extra bottle of Dramamine.
Exactly. Where are you going?
Going out of Boston, we'll go up Maine and then Nova Scotia, several stops, Prince Edward Island, Quebec, and terminate in Montreal.
Well, that sounds good. Well, I'll give you a pretty low chance of hurricane impacts in Montreal.
Yeah, that's true. Probably can't even get a good hurricane drink at the bar.
More likely to get a good glass of wine in Montreal.
Yeah, Phil, it's been great chatting with you. I'm going to turn it over to Hal for any last things he has for you.
Yeah, I was curious if the great New England hurricane of 1944 canceled a Red Sox game. So I just looked it up. It impacted Eastern New England September 15th, 1944. And amazingly, the Red Sox actually played that day and won 11-5, but the game was out in Minnesota. So that's they did beat the Twins, though, 11-5 that day. So you'll be happy to hear that.
All right.
So last question, I was surprised to see some of the SST boxes that you were looking at were more like along the Canary Current from west of Europe down through west of Morocco and Mauritania. Is the logic that eventually that water will kind of shift around into the main development region?
Yeah, and so there's a couple of reasons. So one of the reasons why aren't we just looking at everything in the tropical Atlantic, especially with the August forecast? And one of the reasons is that, if you have the water temperatures, you have the winds, you have the pressures, they correlate very, very highly with each other. So when you're trying to do a statistical model, you're trying to basically say, I want a region that doesn't correlate that much with every other region I'm using, or else you're basically kind of explaining the same variability over and over again. So if you use the low level winds, the upper level winds, the water temperatures, the pressures, they all correlate really highly. And so that subtropical Atlantic region doesn't necessarily correlate as well with what's going on in the tropics. It's kind of like it's basically like an extra factor that can potentially cause other quote unquote issues. And so, yes, you're right. Some of it is that will eventually kind of move into the tropics. The other thing is that if those waters are cool, that tends to be associated with higher pressure that can then cause stronger winds blowing across the tropical Atlantic that can cause weakening or cooling of, or anomalous cooling of the tropical Atlantic for the peak of the season.
So maybe that doesn't correlate as well as El Nino, La Nina, or the SSTs in the main development region, but it's a little bit of extra information that maybe people previously were not looking at.
Correct. Yeah. And that's one of the reasons is that, that's one of the challenges with the statistical models that you want to have. So basically, like the best predictor that we have is like the low level winds in the Caribbean, because that basically subsumes what's going on in the Pacific and the Atlantic because it's derived from pressure gradients between the two basins. So that kind of gives you your ENSO signal and your tropical Atlantic signal. So then we have to say, okay, where else can we get stuff that isn't necessarily quite as strongly related? So we have one predictor over Africa, which kind of gives you a better idea of obviously what's going on over Africa, which is where the storms come from. And then also what's going on more in the middle latitudes or subtropics, and then how that might feed back into the tropics for the peak of the season. And so, yeah, I mean, it's interesting when you kind of build these models because, you basically pick like one thing that goes well in the deep, one thing that basically pick your strongest predictor in the tropical Atlantic, and then everything else kind of is outside of that. And so Bill Gray didn't use low level winds in the tropical Atlantic. And the reason he didn't is because formerly those winds don't change that much. You're talking 1 or 2 meters per second. And we just didn't have the ability to measure those winds that accurately 30, 40 years ago. So now when you look at it with these high resolution reanalyses, we can get to it. You can see like a tenth or half a meter per second, whereas 50 years ago, Bill Gray would use upper level winds because there's a lot more difference in those upper level winds at 200 millibars than there is down near the surface. But the low level winds actually do correlate slightly better than the winds a lot. But if you were to use 200 millibar winds, so winds at say 30,000 feet, those would also work quite well for predicting what's likely to happen the rest of the season.
Thanks, Phil. Awesome presentation today. And thanks so much for being so interactive with all these questions we've had.
Sure. Yeah. Thanks so much. It's great.
Thank you, Phil. We appreciate it. I'll give the honor of the last question to Casper, who asked about the volcano. This is a little lighter question. He says, who has the honor now of ringing the bell on the 20th?
Very, very good question. So actually my supervisor, a professor in our department. His name is Michael Bell. So Michael Bell rings the bell. And so he's rung the bell August 20th. He's rung the bell the last 2 years. And given how robust the response to his bell ringing has been the last 2 years, he certainly has that honor for another year of ringing the bell. So yes, it'll be rung on August 19th this year because the 20th is a Saturday. So when we do our tropical briefing, we do it only on weekdays, not on weekends.
So do you do a YouTube of that for our viewing pleasure?
So I actually have, and I'll post a link to it on the 20th. I actually have one of the guys in our department, so thankfully recorded a video of Bill Gray ringing the bell in 2012.
Oh, wow.
So we have the bell ringing immortalized for posterity.
Great.
That's great. Well, Phil, thank you. What a great presentation today, and echoing Hal, thank you for being so interactive and answering all these questions from viewers and from Bill and Hal and all of us. So thank you, Dr. Phil. We appreciate it. The real
Sure,
Dr.
thanks
Phil.
so much.
Good to have you. I want to thank all our sponsors who make this possibility again. USAA, they've been with us from the very beginning, and we certainly appreciate USAA. The South Padre Island Convention and Visitors Bureau, we will be back on South Padre Island in April. Dr. Phil, you'll be with us again. Looking forward to have you there to make the initial forecast for the 2023 hurricane season. And at that conference, we'll talk about what happened in 2022, forecast-wise and in actuality as well. The weather company, City of Brownsville, Black Magic Design, Weatherboy, Port of Brownsville, Walmart, and all the folks who make this a possibility. We appreciate it. Next week, we will have Lisa Miller, former Florida Deputy Insurance Commissioner, talking about the role contractors play in disaster recovery. That is next Wednesday, August the 17th at 10 a.m. right here, very same place. I hope you'll join us for that. We'll have another discussion, and it should be a good one once again. Again, thanks, Phil, Hal, Bill. Thanks, guys. Happy birthday, Bill. Good to have you here on your birthday. We'll see you all next week. Thanks for watching.